Alright, let's start with heat, specific heat and latent heat. Heat, specific heat and latent heat. So Q equals to mc delta T. So Q is heat, the unit is joules, m or mass, C specific heat capacity, and this is the delta T. Delta T is T final, T initial. Remember that C ice 0.5 calorie gram and C water is 1 calorie gram, and we have latent heat is 80 calorie gram. Okay, this equation, if you see this equation, there must be a delta T, change of temperature. If there is no temperature change, like in change of state, like ice, water, we have to use QML. Q heat, mass, as is latent heat. So the unit for this we can use calorie gram, and is 80 kilogram. This is a constant number. Okay, an example. Okay, 20 gram of ice needs to be melted. How much energy it requires? So 20 gram of ice we need to melt. So melting point or freezing point for water is 0 temperature. So if there is no temperature change, we can use QML. So Q is equal to M is 20 gram and the latent heat is 80. If you multiply this one, we have 1,600 calorie gram. Another example, 50 gram of water needs to be freeze. How much energy needs to be taken from water? Okay, again, Q equals to ML. QM is 50 gram multiplied by 80. This is 4,000 joules. Sorry, calorie grams. Okay, this is must be minus 1,000 calorie gram. Okay, this minus negative shows us water itself give heat, or we take heat from the water, we don't give it for the freezing. Okay, another example. Okay, we want to change temperature of 20 gram of water. We want to change the temperature 10 to 40. Okay, how much needs heat? Q M C delta T. So delta T is T final minus T initial. Okay, T final is 40, T initial is 10. Delta T, T final, 40 minus T initial, 10. This is 30, our delta T. Let's put numbers. M 20 gram seawater. Seawater is 1 multiply 30. Q equals to 600 calorie gram. Okay, another example. Okay, temperature ice is increased to minus 52 minus 10. Okay, temperature of ice. Okay, we start negative 50 to negative 10 Celsius. Okay, for this purpose we use 10 gram of ice. We use 10 gram of ice. Okay, how much heat we need to give the ice? Sea ice is 0.5 calorie gram. Okay, Q sea ice by delta T. Again, delta T, T final. What is the final? T final is 10. T initial is 50. Okay, delta T minus 10 minus 50. Okay, delta T is minus 10 plus 50. Delta T is 40. Okay, Q M is 10 gram, 0.5 sea ice, and 40 temperature. Q, this is the 5 multiplied by 40. Q is 200 calorie gram. This is the minus 15 to minus 50 to minus 10. Okay, another example. If 500 joules of heat is given to 10 gram of water, which initial temperature is 10, what is the final temperature? Okay, the Q is 500 calorie gram. Mass of the water is 10, and we know the initial T initial is 10 Celsius. Okay, let's read again the question. If 500 joules of the heat is given to 10 gram of water, which initial temperature 10, find the final temperature. Sea water is 1 calorie gram. Okay, Q C delta T. C water. Q is 500, tan is 1. Now this is delta T. T final minus T initial. Okay, we know T initial. T initial is 10. Okay, this 1, 0 cancel. 50 equals to T final is final minus 10. 50 equals to let's isolate this one. So 50 plus 10 is T final. Okay, T final must be 60.